Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 2, Truth Table for Conjunction. In the previous video, we discussed what a truth table was in general, although we really haven't seen a true truth table yet in its full capacity. We've only seen one for negation, and frankly, it was a pretty puny truth table. Recall that we're going to make one for conjunction now. Recall that a conjunction is the word and when used to connect two statements into a larger compound statement. The symbol for conjunction looks like a capital A without the line through the middle. By the way, you may have noticed that there are some random markings on the screen. I'm trying something different with my cover and reveal. I'm using white so it's not these big yellow blobs, just to see how it works. I do have to leave some of it uncovered so that I can see where they are. To construct a truth table for conjunction, we start with a generic conjunction written symbolically. So we need two simple statements. Well, we'll use P and Q. Those are our generic pair of simple statements. And between them, we'll put the symbol for conjunction. So we're going to build a truth table for that. Since the compound statement contains two simple statements, P and Q, our truth table will start with one column for each. One column for P, one column for Q, and the final column will be just for the conjunction. So our truth table will have a P and a Q, and then our final column will be P conjunction Q, or P and Q. Just a reminder, when you create a truth table, the first columns are always the columns for the simple statements. And the last column is always the column for the final statement. Now, we haven't seen it yet, and we won't see it until we get to our statements beyond the logical connectives. But eventually, there will be more columns in between. But they will always start with columns for the simple statements and always end with the final statement. Later, you'll see more columns inserted in the middle. Next, we populate the first two columns with every possible combination of truth values for P and Q. This is how a truth table always begins. You list all the possible combinations of truth values for whatever simple statements are involved. In this case, we have P and Q. Each one individually has two different truth values, but together there are four different combinations of truth values. For example, both of them might be true. Or the first one might be true and the second one might be false. Now, if you're wondering why didn't I put false, false, I could have. Or the first one might be false and the second one might be true. Or they both might be false. It technically doesn't matter what order you put these rows. I could have gone true, true, false, false, true, false, false, true. Or any of the permutations of switching those around. But for the sake of consistency, when our truth table involves two simple statements, P and Q to be generic, I will always start the first two columns this way. True, 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 false, false, true, false, false. The way I look at it is we lock the first one in place and then let the second one cycle through its possible truth values. Then we change the first one and then let the second one cycle through its possible truth values. Another way of thinking about it, and computer scientists would scream if they hear me say this, if the T were a 0 and the F were 1, then it would be 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Which are the only numbers you can make with zeros and ones, and they're in increasing order. If that made sense, great. If it didn't, just pretend it didn't happen. Just know that every time I build a truth table that only involves two simple statements, my first two columns will always look exactly like that. In particular, these T's and F's in that order. It's not wrong if you do them in a different order. It's just the way that I will do it from this point forward. I encourage you to do it as well, especially for homework purposes. All right, so now that we've populated the first two columns, we have to figure out whether a conjunction is true or false based on the truth values of P and Q. We have 4 rows, so we'll have 4 decisions to make. All right, to determine the truth value of the conjunction for each row, you'll notice I have the table over here already. To determine the truth value of the conjunction for each row, let's consider a specific case. In other words, let's assign statements to P and Q. For example, we're going to let P equal the statement, I am female, and Q is going to be the statement, I was born in Texas. So the conjunction would be, I am female and I was born in Texas. Row by row, we're going to consider whether that statement would be true or false based on P and Q being true or false. For example, for the first row is true, true. So the first row is assuming that these 2 statements are true. So let's say that somebody says this statement and both of the simple statements were true. In other words, if the person who says the compound statement, if the person who says this is female and was born in Texas, is she saying a true or false statement? So picture it. Pretend I'm female. Pretend I was born in Texas. If I said, or think of a female who was born in Texas. Maybe it's you. Maybe it's a sister, a mother, a daughter, a friend, whatever. But just picture somebody you know who is female and who was born in Texas. If that person says, I am female and I was born in Texas, is that person saying a true statement? The answer, yes. Under those conditions of both simple statements being true, the conjunction is also true. Now, let's try, not erasing everything, let's try another scenario. Let's try the second row. Now, the second row is assuming that the P is true and the Q is false. So this statement is true, but this statement is false. So that would mean somebody is female, but they were not born in Texas. So I want you to think of somebody who's female and who is not born in Texas. It could be somebody you know, somebody you don't know. But you picture a female who was not born in Texas. Got it? If that person says this statement, are they telling the truth? For example, let's pick on Hillary Clinton. I'm pretty sure she wasn't born in Texas. If she said, I am female and I was born in Texas, would she be telling the truth? She would not. That statement would be false if Hillary Clinton said it. By the way, I'm not trying to imply anything political. I was just trying to think of a female that I knew wasn't born in Texas. So, for a conjunction, if the first statement is true and the second one is false, that means that the conjunction, the and statement itself, is false. All right, let's go to the third row. The third row says the first statement is false and the second one is true. So this statement is false and this one is true. So think of somebody who's not female but was born in Texas. I'm an example of that. I'm not female, I was born in Texas. If the person who says the compound statement is not female and was born in Texas, this guy, if I say this, am I saying a true or false statement? Well, I'm saying a false statement. Hello, my name is Chris Chappa. I'm female and I was born in Texas. And for the sake of discussion, let's just assume that female means not male. I know I could catch a lot of flack for that, but frankly, let's not overcomplicate the situation. Would it be true or false if I said the statement, I am female and I was born in Texas? That would be false. I would be telling a lie. So what this tells us is, in a conjunction, if the first statement is false and the second one is true, then the entire statement is false. Let's get rid of all those arrows. All right, we got one more row to go. Let's take a look at it, where both statements are false. I am female, I was born in Texas, If the person who says the compound statement, in other words, if the person who says this is not female and was not born in Texas, I know it says Braun in Texas. Braun in Texas is when the Lakers come to play the Mavericks. I know that was a lame joke. It was a dad joke. Fixed. If the person who says the compound statement is not female and was not born in Texas, is he saying a true or false statement? Picture somebody who is not female and who is not born in Texas. Let's say Bill Clinton. If Bill Clinton says the sentence, I am female and I was born in Texas, is he telling the truth? The answer is no. What he's saying is false. And just like that, we have the truth table for conjunction. So based on that previous example, there's our truth table. Needless to say, this is something you need to know. You can memorize it, it would help. But more important than memorizing it is actually understanding it, or at least coming up with a simple way to determine these truth values over here. So before I unveil a rule, let's see if we can figure one out. If you'll notice, 75% of the time, from a generic perspective, a conjunction is false. So it's usually false, except one time. What's the only time a conjunction is true? The only time a conjunction is true is when both of its simple statements are true. And that's going to be our rule for conjunction. A conjunction is true if and only if all of its simple statements are true. Now, some of you are going to go freaking out because I used if and only if here. We're not talking about biconditionals right there. I'm just using it in the context of that sentence. But a conjunction is true if and only if all of its simple statements are true. Let me basically explain what I mean by if and only if. You can't have one without the other. The conjunction is true. Oh, that means all of its simple statements are true. All of its simple statements are true. That means the conjunction is true. If and only if basically means you either have both of them or you have neither. That's all it means. In other words, the only time this is true, excuse me, didn't mean to move that. The only time this is true is when these are all true. And the only time these are all true is when the conjunction is true. So it's a two-way proposition. It's actually a two-way conditional. Think about it, biconditional. All right, so that's a good rule to have. So let's highlight it because you need to know it. A conjunction is true if and only if all of its simple statements are true. And you can say that rule using fewer words. And is true only when it's all true. That's a common way. Know the rule, know the table. So what could possibly be left? Because you can see a letter peeking out here. This is important to understand as well. This holds for more than two simple statements. And when I say this, I mean this rule. For example, and if you notice, I typed a caret symbol for and. I usually don't like doing that because the and should be about the same font size as the P and the Q, and the caret symbol, which is on the key, on the 6 key, if you hit shift, is smaller and a little bit more elevated, it's superscripted, but in a crunch it will do. So for example, P and Q and R, that's how you could read this, excuse me, that's how you could read this statement. Or you could say P conjunction Q conjunction R, but it's shorter to say P and Q and R. For example, P and Q and R is true if and only if all three of them are true. And it doesn't matter if it's 3, 4, 9, or 200. And so you can say some really bizarre statements that are mostly true until you get to the end. For example, I'm going to say a statement that's false. My name is Chris, that's true. And I am male, that's true. And I am 50 years old, that's true. And I have 19 kids. That sentence was true until the very end. Because for a conjunction to be false, it only takes one of its statements to be false. To be true, the whole thing has to be true. So that's all that is saying, that a conjunction is true if and only if all of its simple statements are true, regardless of whether it's two simple statements or more simple statements. Know this table, and more importantly, know this rule.